Hello. In this video, we do a chain rule review. This is not one of the sections of the book. We are taking a brief break from the book to really go through a bunch of chain rule problems and to emphasize the chain rule because it is so important. It just keeps coming up again and again and again. It's important that you get a good feeling for it. So this will be a short video in terms of the material I present, but it could take a long time because there are lots of problems, and I encourage you, take the time that you need to go through those problems and check the answers. It may take you 45 minutes, it might take you an hour, but do what you need to do to feel comfortable with the chain rule. So first, a quick recap. A basic derivative might look something like the derivative of x to the 10 is 10x to the 9. With the chain rule, we put something more complicated in for that x. So for example, the derivative of stuff to the 10th power is 10 times that stuff to the 9th power, but the trick is, with the chain rule, that stuff that you have on the inside, you need to take its derivative and multiply at the end. Another basic derivative might be the square root. The derivative of the square root of x is 1 over twice the square root of x. In the chain rule, the derivative of the square root of stuff is 1 over twice the square root of that stuff again, but then multiply times the derivative of the stuff on the inside. The derivative of e to the x is just e to the x. With the chain rule, the derivative of e to a function is e raised again to that same function times the derivative of that function. The next thing we studied after the derivatives of exponential functions was the trig functions, derivative of trig functions. So the derivative of sine is cosine. But with something more complicated, the derivative of sine of e to the 8x is cosine of e to the 8x times 8 e to the 8x. So we take the derivative of the outside function, get the cosine, the inside remains unchanged, and then we take the derivative of the inside, being sure to multiply. Recently, we learned about the derivatives of general exponential functions. So the derivative of 2 to the x, for example, is the natural log of 2 times 2 to the x. How does this work with the chain rule? Well, the derivative of 2 to the something more complicated is the natural log of 2 times 2 to that same thing, but then I need to take the derivative of that more complicated thing. This is one that is somewhat simple, but students often miss it. The derivative of an expression like x over 1.05, that's really the same thing as 1 over 1.05x. And so its derivative is just 1 over 1.05. And then we recently learned the derivative of natural log is 1 over x. So the derivative of the natural log of something more complicated is 1 over that more complicated thing times its derivative. And we often put the derivative right on top. Lastly, it's not really a chain rule, but just I want to say a word about implicit differentiation. The derivative with respect to x of y is dy dx. And that is literally just the same thing written in two different ways. But look how we use that when I need to take the derivative of something like x cubed times y to the 8. It is just a product rule, but at the point where I do need to take the derivative of y to the 8, it becomes a chain rule, 8y to the 7 dy dx. Now, for the next two slides, these are a lot of problems, 1 through 12 on this slide and 13 through 24 on the next. Take your time on this. Really give these a try. Make sure you are feeling comfortable with the chain rule. When the answers are presented, I will present them one at a time so you can check your work as you go. So if you want to do the first 2 or 3 problems and then just check your answers on the first 2 or 3, you can do that. All right, pause the video, give it your best try. Go to it. Here are the answers. All right, I hope you did well. Please ask me if you have questions in class or by email. You can refer to the number and I'll know exactly what you mean. Okay, here's the next set of problems. Pause the video, give these things a try, and then start it up again, and the answers will be presented one after the other. Try your best. Here are the solutions. All right. So once again, if you had trouble with something, if something doesn't seem right, make a note of which number it is and be sure to ask me in class or outside of class. I'll be happy to make sure you're thinking all right. I want to make sure that you're on the right track. All right, and that's it for this video.